Hello everyone. So today we will continue with discussion of chapter 2 Differentiation module Cemerlang. So we will discuss question 3 until question 8 today. So first we look question 3. They ask to given the differentiation of 2x squared in bracket 2x minus 2 square equals to hx in bracket 2x minus I in bracket jx minus 2. So the question is find the value of hij. That means they ask to differentiate this expression, then you will get the answer. So you compare and you find what is h, I and j. So what method we have to use? So you use the UV. So first 2x squared will be u and v will be 2x minus 2 squared. Then from there we find our du over dx, that is 4x. dv over dx will be power in front, copy the bracket, power minus 1, then differentiate inside the bracket. So 2x minus 2 times with 2. So 2 multiply with 2, we get 4 in bracket 2x minus 2. So dy over dx, so you start with u, 2x squared, cross multiply, so 2x squared times with 4 times with 2x minus 2, then plus with the other side, 2x squared minus 2 squared times with 4x. So we simplify here, 2 times 4 is 8x squared times with 2x minus 2 plus 4x, 2x minus 2 squared. So from this expression, we factorize. That means we take what is same. So you have 8x squared and 4x, so we can take out 4x. And for the first term, you have 2x minus 2, and the second term also have 2x minus 2, so you can take out 2x minus 2. So from the first term, still left from 8, you just take out 4, that means you left 2x. Now 4x, you just take 8x squared, you just take out 4x, so left 2x. This 2x minus 2 we already take out. Then from the second term, 4x is already take out. Okay, we already factorize. So left is 2x minus 2. Because since it's the power 2, so left 1. So we simplify here. 2x plus 2x will be 4x minus 2. Now we compare with the question. hx. So h is 4. 2x minus I. So 2x minus 2. So I is 2. And jx minus 2, so 4x minus 2, so j equals to 4. So this is for question number 3. Next, we look question number 4. In the Raniza's kitchen, there's a cone-shaped serving lid as shown in diagram 4. It is given that the height of the cone-shaped serving lid is 12 minus u. Okay, the height is already labeled in the diagram, and the diameter of the base is 2u. Okay, diameter is 2u. Where u can be u can be positive lah. That means the u can be positive. Find the maximum volume in centimeter cube that can be occupied by the cone-shaped serving lid. So what you know the height, and you know this is the shape of the cone, and they're asking maximum volume. So you must know the knowledge, your prior knowledge about the volume of cone. So the volume of cone is V here represents the volume of cone equals to 1 over 3 pi r square h. And you know that the diameter is 2u. If the diameter is 2u, what will be the radius? diameter divisible by 2. That means 2u divisible by 2 is u. So the radius is u. So r square, we substitute with u square. H is already given, that is 12 minus u. So from here, we simplify. We just want to open the bracket. So 1/3 times 12 becomes 4 pi u square. Then 1 over 3 pi u square times with u becomes 1 over 3 pi u cube. So this is our V. So the question they're asking for maximum volume. So you must know that for maximum or minimum, when we differentiate, the first order must be equals to 0. So we differentiate first. dV, we differentiate to u. So dV over u equals to 8 pi u minus, okay, these 3 times with 1/3 becomes 1. So minus pi u square, power minus 1. So now your dV over du equals to 0. That means this whole thing, 8 pi u minus pi u square equals to 0. So we simplify this. We bring pi u square to the right. So becomes 8 pi u equals to pi u square. So we can just cancel the pi. So u equal to 8 from here. Then they want the maximum volume. So you substitute 8 into the volume expression that we found just now. So 4 pi 8 square, u square is 8 square minus 1 over 3 pi 8 cube. So when we solve here, we will get 85 1 over 3 pi. So this is for question number 4. Next, for question number 5. A can of milk with its lid open has a height of 8 cm and radius r. If the surface area of the can of milk is L, so they ask to show L. L is equals to pi r square plus 16r. So you must know that a can, what is the shape of the can? It is a cylinder. So they're asking for the area. So you must know the area of a cylinder, that is equals to 2 pi r square plus 2 pi r h. Have to remember, and this is a prior knowledge. So the area is given as L, so we substitute with L equals to, okay, now the lid is already open, so you only have one circle that is at the bottom. So you have pi r square, only one circle. So plus with 2 pi r 8. 2 pi r h. H is given 8. So we just factorize. That means we take out pi. So we'll get L equal to pi r square plus 16 r. So we already show for part A. Then for part B, then find the approximate change in the area of the can of milk if the radius of the can milk decreases from 4 to 3.98. Approximate change in the area, that means we are going to find our delta A, delta L, supposed to be delta L, since they said the area is L, so it's delta L. Okay, so first we find the changes in R, approximate changes in R. That means we take the new value 3.98 minus with 4, so we get negative 0.02. Then from here we know that our L is pi r square plus 16 pi r, so we differentiate the L over the r, so becomes pi r square becomes 2 pi r, 16 pi r becomes plus 16 pi, and we substitute with r equals to 4, the origin value, okay, for this 4. So it changes from 4. That means we have to substitute from r equals to 4. So 2 pi times with 4 plus 16 pi. So we simplify 2 times 4 is 8. So 8 pi plus 16 pi equals to 24 pi. So this is dl over dr. So we are going to find the approximate change in area, delta L. This is delta L equals to dl over dr times with delta r. So 24 pi times with negative 0.02. So you will get negative 0.48 pi. So this is for question number 5. Next, we look question number 6. Zuraini tapped a piece of square metal with a circular hole in its middle as shown in the diagram 6. That means this is a square, a piece of square metal and got hole, a circle in shape of circle in the middle while walking along a football field. The diameter of the hole is 2x. Diameter is 2x, so you must know the radius will be divided by 2, that is x. And the length of the edge of metal is 2x minus 1. So this since it is a square, so the length and the width are same. When heated, the metal expands such that its sides increasing at a rate of 0.1 centimeter per second. Find the rate of change of the radius of the circle. So when the metal expands, of course the circle also will expand. That is you must know, okay? You must know that when the square expand, the circle also will expand. So when the metal expand at the rate 0.1, of course the circle also have to expand at the rate 0.1. So our rate of change of radius dr over dt will be same as the metal, 0.1. Next, for part B, they ask the rate of change of the area. That means dA over dt of the metal when x equals to 2. So dA over dt. How to find dA over dt? So area of a metal, first we find area of the metal first. How to find the area of the metal? We take the area of the square minus the area of the circle, because you got hole, the circle is the hole, that is not a metal. So square length times width, 2x plus 1 times with 2x plus 1. So we get 4x squared plus 4x plus 1. Expand the quadratic minus the circle pi x squared. Our radius is x, so pi x squared. So we differentiate our area dA over to dx. So 4x squared we get 8x, 4x we get 4, 1, 0, pi x squared we will get 2 pi x. So we substitute with x equals to 2 from the information given in the question. So 8 times 2 plus 4 minus 2 pi times 2. So we calculate, we get 7.4336. This is our dA over to dx. The question asking for the rate change of area dA over dt. So how we want to form dA over dt is a dA over dx times with dx over dt. So we know dx over dt is already given in the question, that is 0.1. dA over dx we just found in just now, that is 7.4336. So we multiply with 0.1, we will get 0.74336. Next, for part C, they ask to find the value of approximate change in the area of the metal when the side increase from 2 to 2.01. So we find the approximate change. You want to find the approximate change. of the area, that is dA over dx times with delta x. So our dA over dx is 7.4336 already fine. Then times with the approximate change in the side given, 2.01 minus 2, so you get 0.01. So multiply with 7.4336, you get 0.0074336. So this is for question number 6. Next, we look question number 7. This question is also in your textbook. You can refer your textbook, but not the same question, just value differ. So diagram 7 shows an an inverted cone with a base radius 10 centimeter and a height of 20. So this question also we have done in the class. If the height of water in the cone is given is T, if the height of the cone if the height of the water in the cone is T, show that the volume of water V in the cone is V equals to 1 over 12 pi T cube. So first, from here, radius is 10 and height is 20. From this information, what we must do, we have to find the ratio. Okay, we find the ratio R to H. So R over 10 equals to H over 10. So from the ratio, or proportion, we will get R equals to 1 over 2H. So from there, we know another one, you must know the your prior knowledge on volume of cone. So volume of cone is V equals to 1 over 3 pi R square H. So 1 over 3 pi, so from here we know our R. R is half H. So 1 over 2 H. H is already given us to substitute with T. Okay, the height of the water in the cone is T. So we have to substitute H with T. So half T square times with T. H is T. So half square is 1 over 4 times with 1 over 3 becomes 1 over 12 pi T cube. So we already show for part A. Then for part B, water leaks out through a small hole at the tip of the cone. So leaks out means the volume is decreasing. So find the small change in the volume of water when the height decreases from 4 to 3.99. So from here, for part A, we already find the volume. So for part B1, we differentiate the volume. That means 1 over 12 pi T cube. When we differentiate, we just bring the power 3 over 12 pi T square. That when simplify becomes 1 over pi T square. Then we substitute with from where? From 4. So we substitute the value 4. We substitute T equals to 4. So 1 over 4 pi 4 square. So we simplify, we get 4 pi. And another information given is the T. T decreases from 4 to 3.99. So we find our delta T approximate change in T, that is 3.99 minus 4. So you get negative 0.01. So question is to ask small change in volume. So change in volume becomes 4 pi times negative 0.01. So you multiply, you get negative 0.04 pi. Then for the second part, they asked to show that a decrease of K% in the height of the water will cause a decrease of 3K%, okay, in its volume. So if T decreases by K%, T is the height, decreases by K%, so that means your delta T here is negative k percent, because decreases. If increases, positive. Decreases, negative k over 100%, means over 100 times t equals to negative kt over 100. This is your delta t. Then how to find your delta v? Delta v is dv over dt times with delta t. So dv over dt is 1 over 4 pi square times with negative kt over 100. So you will get, this is delta t that we get from here. dv over dt, we get just now 1 over 4 pi t square. Without substitute with 4. The substitute with 4 is for the question B1, because they asked from 4. Now it's a different question. You cannot substitute with 4. You cannot take dv over dt is 4 pi. You have to take 1 over 4 pi t square. So when you multiply these two, you simplify, you get negative kt cube pi over 400. Then we want to show that delta V, maybe I can write delta V over, we want to find the percentage, delta V time over V times with 100%. 100%. So our delta V is this, negative, we take negative kt cube pi over 400 times over V, right? Divide by V lah, divide by V. So I change it to multiply. I change it because it's a fraction. I want to change it to multiply over V. So what is our V is pi t cube over 12. So I change it, becomes 12. Because when divide, sorry, now this is 12. 12 over pi t cube, and don't forget to multiply with 100%, 100%. So you can cancel this t cube lah, t cube with this t cube, then pi with pi, then you multiply 12 times 100, 1200 divide by 400, so you will get negative 3k. So from here you must write the conclusion. Okay, you will get negative 3k. So from here you write the conclusion, the water will cause a decrease of 3k%. Okay, since you got the, here got percent, 100%, you can write negative 3k%. So we already show that if the height, okay, decrease k%, the volume also will decrease 3k percent. Okay, this is for number 7. So for question 8, Yusri wants to build a closed cylindrical container as in diagram 8 to store rainwater for daily use. So given the area of the curvical surface, that means the curved surface here, okay, the curved surface here is 0.8 pi r, and the area of its cover and base A2 is given by A2 equal 2 pi r square. That means the top one and the bottom one is the circle. Yusri was informed that the cost of the material for the curve and the cover and base is 125 ringgit for 1 meter square and 200 ringgit for 1 meter square respectively. That means the curved surface part is 125, the circle part is 200. So the question is determine the function P for the cost of material to build the container. Hence, calculate the minimum cost to build the container. So first we want to determine what is our P. P is the cost. Cost means we take the area times with the cost. So the area for the curved surface is 0.8 pi r. So we multiply with the cost is 125 plus with the circle part bottom, top and bottom 2 pi r square, 2 circles times with 200. So we simplify, we get 100 pi over r plus 400 pi r square. Then the question they ask to calculate the minimum cost. So you must know that for the minimum, maximum, our first order, differentiate of the first order must be equals to 0. So we differentiate, so I bring the r up, so it becomes 100 pi r minus 1. So we differentiate negative 100 pi r, the power minus 1, negative 2 plus 800, 2 times 400, 800 pi r equals to 0. So we simplify this, we bring our negative 100 pi r over r square to other side, so to the right, no? So becomes equals to 100 pi over r square. Then the r square we multiply with r becomes r cube equals to 1 over 8. So our r is half. Then from there we substitute into our P. Equation P, that is 100 pi over r is 1 over 2 plus 400 pi times with 1 over 2 square. So we get 942.48. This is a cost. Cost means involve price. So we take 2 decimal places, 942 ringgit 48 cent. So I hope you all understand the explanation given. So thank you.